welcome to day 19 of our 30-day coding challenge from CS and Math. Today we're going to be focusing on a pillar of computational thinking called pattern recognition that we talked about before. And from a math perspective, this is definitely one of our favorites. This is from a 30-year teacher, veteran teacher from California named Fawn Wynn. You can find her at Fawn P. Wynn on Twitter. And she has a blog she keeps, and if you're not following her, you might as well go ahead and just click that follow button. But anyways, she created this with a couple other people, but it was her that kind of curated the deal, and it's really a strong way to introduce equations, any type of pattern recognition in algebra, really. So let's go ahead and dive into it. Now, the thumbnail of this video that I chose here is, it's really a warm-up routine, but it's really a thinking routine that was popularized by Christopher Danielson, who's also on Twitter, and it's called Which One Doesn't Belong. So you notice you'll have 4 parts: upper left, upper right, lower left, lower right, and your goal is to say which one of those 4 code snips doesn't belong. Good. Now, hopefully you paused and picked one. If you didn't, you should pause right now and pick one and have a reason to back up why you said that one doesn't belong. And the idea is that all of them could potentially not belong. There's no correct answer here, but you'd pick one and have a reason for why you think that one does or does not fit. Now, the pattern was actually this pattern of puppies, if you didn't catch it in the middle, and that's where we're going to work on programming. I'm not going to tell you what the correct answer is, but I suggest that you run this with other teachers and kids. All right, now the standard way that we approach these visual patterns in algebra is to try to generalize, right? We try to see the pattern. So if I went back to the puppy, big picture of the puppies, you'd say, well, it starts with 1 puppy, goes to 3, 5, 7, but more so, could you identify like what's staying constant and what is changing? And so there's a lot of ways you could look at that. I don't want to give away her full kind of deal here, but essentially I could say, for example, this 1 puppy to me in the upper left seems to stay constant. That's the way I see it. And then there's these diagonal rows of 2 that kind of keep adding to change. And what we'd look to do is have kids see that, explain it, explain their pattern, highlight the picture. You'd want to give them the picture. But in terms of programming it, you would have really 3 pieces. And we have a lesson we'll probably do just on this, but it works kind of like this. You'd want to say, is there any like user input that we want? Maybe I'll just start it off by saying, well, we want to know what step or stage number. I don't know if you saw here down at the bottom, it's pretty small font, but it says puppies in stage 43. The patterns on this site default to the 43rd step because kids are trying to capture the generalization and project it out to the 43rd step or stage. So I'd say, well, the number of puppies in this case is equal to, the starting value was 1. So it's like, that's like the intercept or initial value was 1. And then we'd say plus, 1, plus, and then we'd want to do 2, like the constant rate of change is 2 and 2 and 2. You're constantly multiplying by 2. And there's a way, again, that you could map this on the paper, but essentially you're going to take that constant rate of change like a slope, if it's a linear pattern like this, and we'd multiply that by the stage number. Now, it depends on if you call this a 0 term or a first term. I'm going to call this like the first picture, the first term. So then I would want to offset the stage number by 1. And then I would say, so puppies equals 1 plus 2 times the stage number. And then I just have to display that. It'd be like a 3rd step where I print puppies. Isn't that easy? So if we run this, it prints 85 puppies. That would be at stage 43. Okay, and you can see here that at stage 43 there are 85 puppies. So this would be like an explicit approach. This we call in math an explicit equation, one that I could easily change this value of, or even prompt for. I could ask for the input from the user and say how many, or maybe just say what stage would be good. This is going to default, though, to a string of text. You actually have to convert that to an integer, so I'm going to put that around here. And this is a really fast way to just say, okay, what stage number? We want stage 43, hit enter, and that's 85 puppies. And you can make this look prettier if you want to. There's a way you can change this print statement. We've covered a lot of that, though, in some previous videos, which you could then add in if you wanted to. But is there another way we could look at this from like a programmer's mindset? One that's more based on the previous turn or iterations? And so in math class, we say things that are based on the previous term. We call that kind of recursive recursion. Whereas if you talk to a programmer, you talk about recursion, they usually think about like a function within a function. We're going to use the math concept and say, okay, what if I started with the initial number of puppies? The number of puppies in that first picture was just 1. And I just want to build the next term off of that and the next term off of that. So each subsequent term is built off of its previous term. And this works really well for our looping structures in programming, right? So I'll start with a for loop. So for item, I'll just put I in range 1 to 43. That means start at 1, go to 43, because we're starting with the first term, right? And keep incrementing those number of puppies up. So it'd be like puppies plus equals 1 or 2. Sorry, constantly changing by 2. Now, just so we got this, let's just print something smaller like the third one. And I'm going to put the print statement right here, right within the loop. Now notice the indentation. I think we've talked about that a lot, but just in case you're new for today, indenting means it's inside of this for loop. So if I run this, notice it says 3 and then 5. So prints, I already had 1 saved, and then it prints 3 and then prints 5. So 5 are what are in this third picture. Okay, so we notice that it's printing this upper bound number. So if I change it to 4, it's going to loop 4 times. Even though it doesn't print this first number because we didn't tell it to print until after we incremented up. We could add a print statement after this one, right, to get them all in there. But notice that those numbers are matching what we want. So then I could say 43 here and run this, and it will run the full sequence. Or I could take it out of the loop and just print it at the end like this. So we've really figured out that iteratively, now this would take forever to do on paper, which is the idea we're trying to get away from. But if you partner your knowledge with computers, now we've got a structure where you can loop this quickly. So this fits this type of pattern very well. If this incrementing concept doesn't make sense, all we're really doing is taking the puppies and setting it equal to whatever the previous value of the puppies was, plus 2 more, right? So this should print the same exact thing. Yeah, so it does the same thing, so it doesn't do anything. But there you go. So now we have some basics. Let me just think and see if I want to close with anything real quick. You know what? I didn't put this one, so if I go to the which one doesn't belong here, I included Scratch, but this is a Python tutorial month or a Python challenge month. One thing I thought about putting in there was a different type of looping structure, but I didn't because it requires you to then make a second variable. Let's say I started at stage 1, so I made an initialized or declared a variable called stage 1, or called stage, and I had it receive the value of 1. I could actually change this for loop to a while loop, another type of loop. So while the stage number is less than 43, make the puppies equal to puppies plus 2. And if I wanted to, again, put that back to plus equals 2, then I could actually increment the stage number up as well. So plus equals 1. And sometimes that's more advantageous, but notice that also prints 85. So a while loop could work. Lastly, to finish the video off, it's covered in previous videos, but just in case you wanted to, let's say I wanted to make this say like something puppies, so then I could say plus puppies. And then this would actually produce an error. We've talked about this in previous things because it's trying to add a number, because puppies is a number 85, and it's trying to add it to what's called a string as a type, object type. So I would want to actually convert this integer puppies to a string when we print it out like this. So notice how it prints puppies. Now there's needs to be a space here probably to make it clean, but you could then put this in there. You could put in parentheses. Some people in the older versions of Python, I believe it made you, if I remember correctly, it made you put parentheses on there. It still can work that way, but it would make a nice print statement. Okay, well, thank you guys. Hopefully you learned some things, and we'll catch you next time. Hit that subscribe button, hit that like button. See you next time.